We have already spoken about naming saturated hydrocarbons, or the alkanes. And in the last video, we began our discussion of naming unsaturated hydrocarbons when we spoke about the alkenes. Now we are going to continue our discussion of drawing and naming unsaturated hydrocarbons by speaking about the alkynes, or the third member of the homologous series of hydrocarbons. Alkynes, if you look at table Q, you will see that they have a general formula of CnH2n-2. And that is because the alkynes have one triple bond between the carbons. This is similar to the alkenes that have one double bond between the carbons, but the alkynes have a triple bond between the carbons. And because there is a triple bond, they are also considered an unsaturated family of hydrocarbons. If there is a triple bond between carbons, what is the smallest organic compound possible in this homologous series? Can you have methine? Well, no, methine cannot exist. And that's because you have to have a triple bond between two carbons, and therefore the smallest member of this series must have at least two carbons. So the first member of this group would be ethyne. Ethyne, eth for the prefix to, ine for the fact that it is an alkyne and has a triple bond between carbons, looks like this. You have a carbon triple bonded to another carbon. This carbon has a bond to a hydrogen because it already has 3 bonds and needs a fourth. This carbon is bonded to a hydrogen because it already has 3 bonds and needs a fourth. And if you remember the general formula, CnH2n-2, then if C is 2, right, C2, so the N is 2, 2 times 2 is 4, minus 2 is 2, giving you the formula C2H2. The next member of this group would be propyne. Propyne looks like this. Propyne has 3 carbons, 1, 2, 3. If you look at the formula for the alkyne, CnH2n-2, if N is 3, then 2 times 3 is 6, minus 2 is 4. So it's only going to have 4 hydrogens. This carbon gets 1 hydrogen because it already has 3 bonds right here. This carbon doesn't get any hydrogens because it has 3 bonds here and 1 bond here. And this carbon, since it only has 1 bond, can get 3 more hydrogens. Is there an isomer for propyne? So when we discuss propyne and you wrote down 3 carbons with a triple bond on the first carbon, you really drew this structure. This structure. Hydrogen bonded to carbon, triple bonded to another carbon, single bonded to a carbon that has 3 more hydrogens on it. The only other place you can put that triple bond would be between the second and third carbons, giving you this structure over here. But really, that's this structure. A carbon with 3 hydrogens, single bonded to another carbon that's triple bonded to another carbon, and that last carbon has 1 hydrogen on it. So therefore, propyne does not have a different isomer because the only other place you can put that triple bond really gives you the same structure. Draw the structure for butane. So in order to draw butane, C4H6, you should start with 4 carbons. You know that it has a triple bond, so you put a triple bond between 2 of the carbons. Now there's different places you could have put it. You could have put it between the first 2 carbons or between the second 2 carbons. And then continue to put your hydrogens where they belong. This one gets 1 hydrogen, this doesn't get any, this one would get 2, this one would get 3. And this would represent 1 butane. Here, this carbon would get 3 hydrogens. This wouldn't get any, this wouldn't get any, and the last one would get 3. And this would represent 2 butane. So here I have the models for both 1 butane and 2 butane. This would be the model for 1 butane. right? So we have carbon triple bonded to another carbon, single bonded to a carbon, and single bonded to another carbon. And it would be 1 butene with a triple bond in the first position. Here I have 2 butene, where I have a carbon single bonded to another carbon, which is triple bonded to a third carbon, and single bonded to the fourth carbon. And this represents 2 butene. You may argue that you could put the position of that triple bond in the third position, between the third and fourth carbon. If you did that, you would get the following structure, which really is just the mirror image of that structure. So for instance, here I would have this structure, a carbon single bonded to a carbon, single bonded to a carbon, triple bonded to another carbon, which is the same structure as 1 butene. So this does not give you a different structure. This is the same as 1 butene, and therefore there are only 2 isomers of butene.